Hi, this is Dr. Graves with the CSUN Geography and Environmental Studies program. This is a video tutorial designed to help students in Geography 107, Introduction to Human Geography, or something called landscapes and God knows what nowadays, complete the Doughnut Shop Site Location Lab, in which you will locate both a new donut shop in Los Angeles and also a warehouse for delivering supplies to donut shops and bakeries. The map that you see on the screen before you has multiple layers. The donut shops, which I'll turn on and off. Here's a couple of warehouse operations, one a blue square and one a red square. You can turn on and off the streets layer if you want to zoom in and get a better idea of what's going on, and in the background census data that represents the potential customers. Turn that off, and then a zip codes layer that will help you identify the neighborhoods more quickly. You can turn that on and off. And one of the first things that you'll be asked to do is, just to remind you how to do this, is to identify a couple of the donut shops by turning on the zip code layer and then perhaps zooming in and answering a question. Turn off the zip code layer and move on to the first substantive operation, in which you will try to locate the least cost location for establishing a warehouse in which the delivery trucks make a daily delivery to each of the donut shops. In order to do that, we need to click on the Analysis tab, click on the toolbox, and over here in the toolbox, type in mean center under the geoprocessing window. Mean center. You've probably done this before. Select mean center by clicking on the tool. When the mean center tool dialog box appears, the input feature class is donut shops. The output feature class may auto-populate, so I'll just put a 1 after that to indicate this is the first time that I've calculated this. There is no weight field and there is no case field in this version of the calculation. Click the Run button and wait a moment as the software calculates the mean center. After a few moments, a mean center will appear as a green dot on your map, and at that point you can answer a couple of questions. Under a different set of assumptions, you would not use the mean center. Under a different set of assumptions, in which you deliver only occasionally to some donut shops and more frequently to other donut shops and bakeries, then you would want to locate the warehouse for the bakery supplies closer to the donut shops that require more deliveries. That is a different kind of analysis, the minimum travel model, and in this instance we will run this again. You can just leave this window open and call this, I'm going to erase mean center here. You can either just add a 2, or I'm going to put WMC for weighted mean center 1, because now we're going to have a weight field indicating sales. It will move the warehouse closer to the donut shops that have greater sales and therefore demand more deliveries. the rest of the case field and the dimensions field can remain blank. Click Run, and a second calculation will be performed. A second green dot will appear, and because it's called WMC for weighted mean center, or if you just called it mean center too, just double click on the green dot and change it to a different color by clicking on properties and change it to something different. And maybe I'll make this a kind of a chartreuse dot instead, and there it appears on the map. Once that's available, then you may want to zoom in on it and answer a couple of additional questions. And now you can turn off your warehouse options, because we're finished doing warehouse site location, and we're going to switch to how to locate a new donut shop if you were an entrepreneur and you wanted to go in to the San Fernando Valley. Your goal is to find a location that maximizes the potential customers that would live close to you while minimizing the competition that would be near you. In order to do that, we need to draw trade areas around each of the donut shops. And we're going to operate under the assumptions of the hoteling model, which suggests that customers tend not to bypass a donut shop or a one store of some sort to go to another if they offer essentially the same goods, and we are assuming that the donuts are of generally equal quality and price. Click on the Analysis tab again if it's not already activated, and click on Tools, and in the Geoprocessing window type Thiesen, Thiesen, and you will see the tool called Create Thiesen Polygons. Click on it. The input feature is donut shops, and the output feature is donut shops create Thiesen. If you want to change that to something different, you're welcome to, like trade areas, but I will leave it at create Thiesen. The output fields, we don't want only feature ID. Let's have it put all fields so we will know what the name of the donut shop is inside each of the trade areas. Click Run and wait a moment. Okay, so now we have Thiesen polygons, and if you find this sort of spider web somewhat disturbing, double click on the purple or the swatch, color swatch over in the table of contents, and if you want to change the color, change it to no color, and maybe make the outline width a little bit bigger, and click Apply. And then what you can see as you zoom in is that this polygon here is the trade area for this donut shop, A Good Day Donut, and inside this are all of the people or the addresses in which this Good Day Donuts is the closest location. We have one additional step to take so we can find out how many people live inside this trade area and what their purchasing power is. So it's sort of a two-step process. So the first thing that we need to do after you answer some questions, so you may want to pause to answer those questions, is that we need to transfer the data from the census tract layer, which has all of our information about potential customers for our donut shop. We need to make it so that we can transfer that over easily. So click on the census tract layer, click on the tools layer, and in the geoprocessing window, type in feature to point and select the feature to point tool. What that's going to do is convert the census tracts as polygons to census tracts as points, which makes it easy for them to join to our trade areas. So the input feature class is census tracts, and the output feature class will be census tract feature to point, and click run. After a moment, you can see that each of the census tracts has a point in it, and that these census tract points have all of the information associated with the polygon. And you can turn the census tract layer off and just leave the points on, if that helps. The next step is to right-click on the Thesan layer that you have, or the trade area, and when you right-click, that's a two-finger click on some devices, click Joins and Relates and add Spatial Join, which will allow us to add all of the data from the census points into the trade area. So it already recognizes that our target feature is the trade areas, the Thesan polygons, and the join features are the census tract feature to point layer. And we want it to intersect. So click on Fields at this point, and this pop-up window changes. Click on Population. Click on the Edit Field Properties button, which looks like a pencil, and change population field property, the action, to sum, because we want to count up all of the people in each of the trade areas. Click on income and change its action from first to average. So we want the average income and all of the people. Click OK and click OK. And the spatial join will be complete. There's a intermediate step that you must do now in order to calculate the purchasing power. You may want to stop here and answer a couple of questions about these Thesan polygons. You can right-click if you would like and click on the symbology, change it to graduated colors, and change the color ramp to map, for example, income. And you may want to answer a question about that. There may be a question about the size of the populations that are inside, or even simply the size, the shape, area. You can manipulate the number of classes to help you identify likely candidates for the answers, and perhaps different color ramps, change from natural breaks to equal interval, and sometimes the answer becomes far more evident. This ends part 1 of the video tutorial.